I was assigned to teach a Java class. And I find the textbook extremely boring. So I started building this thing off of the Java platform. So I have been teaching computer science since, oh gosh, every time I talk about this, it just surprised me. Since 1999, so it's been a while. I've been teaching object-oriented computer programming, mostly to first-year computer science students. But even for first-year computer science students, I noticed a few things right away. I noticed that object-oriented concepts are usually very abstract. It's hard for students to understand it in a concrete way. I mean, we can talk in vacuum about, creating these objects, inside inside your program, but what does it really mean? And most examples that I find has to do with kind of like the basic hello world. You have your you have a lot of it is just text based in terms of all the examples from the books. The input, they always ask people to type in input and then process some kind of input and they calculate, let's say, the circumference of a circle or some things like that, which is really difficult, I think, for students to identify with the material and see how it actually relates to their everyday life. What I find is that students generally like to have examples that they can identify with, that they actually have personal experience with. And I also enjoy giving them some room to be creative. Now, I mean, computer programming is by default a creative activity, but you don't, and I actually talk about it here in my TED talk that I did last year. However, most of us are really don't have the tools, I believe, to make things creative for them, make the computer programming activities creative for them, because there's this mountain of knowledge that you need to have before you can be creative. I want students to have a sense of accomplishment, and above all, I want everything to be cloud-based so they can access this software and access their projects from anywhere in the world. So those are some of the challenges that I noticed in the years of me practicing teaching computer science. So that brings us to this tool that we have been working on. It's called, you can just visit it. It's java.c3d.io, and you can get there pretty easily. It is a web-based platform that focuses on producing 3D and virtual reality environments, and it is focused specifically for computer science students. And I created it. Actually, the first version, I suppose, of it was a desktop version that I created back in 2006. And it just kind of evolved and it grew. It just was more of an experiment. It wasn't really meant for as a product for people to use back then, but things evolved very quickly. And the latest version of it is a web-based platform that requires no install, but it is still full-blown Java. And you'll notice that compared to a lot of the other cloud-based Java platform, that java.c3d.io has, because it's focused on 3D and VR experience, that students get to create interactive environments very much like a video game that they can relate to very easily. And they can share it with their friends, their teachers. Unfortunately, it's still active in development. We sometimes call it still in beta. So I love to hear some of the feedback from everybody. And for now, please stick with Google Chrome as the web browser to launch the product until we start testing it at a more elaborate and thorough way. So I just wanted, so let's just jump right in to the product. So I'm gonna exit out of my presentation and jump right into the product right here. So this is the basic product. If you visit, I mean, I can here refresh it. If you refresh, you get a basic world, so to speak, and some starter code. But we're actually gonna create our own starter code. So for the rest of the presentation, what I will be doing is going over a couple of the basic concepts that is difficult to express when we are teaching when we are teaching beginner computer science. And I want to illustrate how we express those concepts here inside the java.c3d.io software, just so that you can compare and contrast how things work differently. So for lesson 1, for example, the very first lesson that when we try to teach Java, when you try to teach object-oriented programming, is a few basic concepts, right? Things like objects are the basic building blocks of a object-oriented programming or object-oriented program. However, we actually don't write objects directly. We write things called classes, and from classes we create objects. And then, of course, we tell our students objects would have things like fields, it would have things like methods, and a couple other things like, oh, you know, you only call methods, you don't interact with objects directly, and then a typical program contains many objects. That's just a big mouthful of terminologies, and it makes it, like, I don't know about you, but I find it, just saying those terms will confuse the heck out of anybody if they have never seen this before. And a lot of the basic textbooks will go through these concepts. We'll go through, okay, now we're going to drill down to what classes are and stuff like that. And I find it could be fairly dry, and it lacks some kind of motivation. So I personally like to jump into an example right away to make it come alive, and that's where the java.c3d.io tool will help. So instead of looking at this starter project, which actually is a little, it already has some of the concepts already built in, I kind of want to start from a even simpler program. So if you visit this link, so here is share.c3d.io/e. So if we visit this link, you will see that it actually overwrites the world into a much more basic world. So let's focus on this file called ball.java right up here. As you can see in the virtual environment, so to speak, which is the right-hand side of the screen, you'll see a kind of an empty room. That the reason why there's an empty room is just for spatial relationships. So that it's easy to illustrate to students where when we are placing an object, you know, where the object is. Later on, we can customize the room or get rid of the room altogether when we are building a bigger object. But if you look at the left-hand side, this is where the actual code is written. And on the top, you have different Java files, if you will. But right now, I just want to focus on ball. So what you're seeing here is that there is a class called ball, and this ball that you see in the middle of the screen is created from this class. And the way that we look at it is, if you look at the highlighted lines, these are what we call fields inside this ball. So this ball has is a 3-dimensional ball, so it has 3 fields, X, Y, and Z. Each field has a data type, and this is called the double data type, which means that it can take decimal points. For, you know, when I explain to students, you know, in the first lesson, that's what I would say to them, that double just means a number that can take decimal points. And the word private just denotes that it is a field within the class. And here, inside this block that says public, this is essentially what happens when we create the ball. So when we create the ball, the X, Y, and Z fields will be set to a particular location. In this case, 5, 1, and 5. And a lot of times right now, I would right away ask students the question, so how big do you think the room is? And all they have to do is kind of make changes to the different parameters or to the different fields, if you will, and they can experiment and see how big the room actually is. So as you can see, you can already take a look at, you can see from the programming area that when I make changes to the computer program, I have to click the run button, and the new version would the program would run in the window, in the 3D window. And as you know, so I would ask students that, and they can right away, they can have a sense of how big the room is. So the solution or the answer is that the room is 10 by 10 by 10, and the far lower left corner is 0, 0, 0, right? The far lower corner, and the center of the ball, as you can see here, the center of the ball is actually right, like the center of the ball is where the coordinate is located. So you can they just have a bunch of fun doing that, and I can enjoy explaining some of the concepts about fields, right, like this ball. But if you switch over to game, for example, then another I can illustrate to them that this program, the class, is just how we create the ball. So we actually create actual ball objects out of a ball class, for example. So if you go to game, you can see that, and I would just focus on these 4 lines. This is the start method of the game, starts the computer program. And I would essentially focus right here in that the env add object will put a new ball into the 3-dimensional environment. So that's kind of what I would say to them, right? Is that this new ball creates a new ball, and the add object adds the object into the environment. And there are many various little exercises or various ways to illustrate this. So sometimes I would actually create additional fields in the game class to say to tell them that, a ball could now, like, we could have multiple balls and so on and so forth. But I want also to focus on something a little more fun for students. For example, this particular ball, I make it really dull on purpose because it's not exciting, and I want them to have some creativity. So I would explain to them that, there are other fields that you can put into this class. There's a field called texture, something like that, right? And so I would start explaining that, okay, so each field would have different data types, right? We have seen the double data type for the Z field, which means that Z is a number that has a decimal point. And why do we need decimal point? Because we sometimes want to have stuff like this, where we make sure that you can move around. But as you can see, as I change this, the texture is no longer there. The kind of the Earth default texture, the boring planet texture, is no longer there, because here I assign the textures to nothing. So there's actually no texture. It's just random colors, if you will, in this particular case. But texture has the data type string. And when there's a data type string, we have to put double quotes around it because we are putting in a word or some kind of text, right? We can type in some pieces of text here. What is this text? This text would be something like a description, an image, a link to an image, if you will. So I can say, so this is one of the basic image, right? So now it looks like a bunch of marble. I like to use this silly looking image, which looks like a My kids tell me that looks like a really ugly ball, and they got freaked out with the eyes. So, but you can actually put in your own image, any image that you have, as long as you provide a URL directly, right? You can actually link to any image that you want. So, and I would then tell students, so here, there's another interesting thing that I could use, another interesting field that I could use, called models. You're probably wondering, well, where do you find all these images and models and things like that? Well, I'll show you this first, and then I'll point you to the proper place where we can find it. Oh, sorry, typed it wrong. They are in here. So as you can see, is that now we have a little penguin. So there is this other field called model, which if you point to an object file, an OBJ file, it would actually put in the geometry of whatever you can create using a 3D modeling software, something like people have used SketchUp to Google SketchUp to create that. There's also, Tinkercad can also create these type of objects with a texture applied on top. So I can share the link here, but if you can see, these are some of the basic models that are available. So if you go to under models, I have a bunch of basic models, and Tux is right here. Tux, the basic Tux model is right here. And you can see tux.obj and tux.png, they are right here. But I have other built-in models as well. So if you don't provide a full-blown URL and just use the models / then you are accessing this particular directory. And so there's another one called Fox. So if you look at this, another directory called Fox. So let's take a look at what Fox looks like. And there you go. That's our little fox. I mean, we could continue on. At this particular point, I would end my lesson 1. There's actually a lot of things already to throw at students. I would at this point end lesson 1 and start asking them to do a few follow-up questions and projects, right? I would show them, actually, I would also show them how to decorate the room, if you will, how to change some of the walls and size of the room. I will show them the full-blown set of properties or fields that a class can have in order to fully manipulate the object. And then I'll also ask them to create multiple objects, if you will. Actually, maybe I'll do this one, to create multiple objects, just because it could be a little fun. So so this is the ball class, right? So I could actually create another class. Let's say I call it the fox class or something like that. So I can add, so now there's a fox public class object. So let's say ball, I actually change it, I delete this, so that the ball is just a regular ball. So here the ball becomes regular ball. For the fox class, I would still use hey, I can't spell for some reason. So in this case, I'm just showing them how to create these things from scratch. I can say that x is 1, y is 1, z is 1. But I could also actually, this is what I'll do. When I'm teaching beginning programming, I like to make sure that everything is properly laid out. So I would tell them, although you could actually assign values right here before the constructor, I would actually tell them, don't assign anything here, right? I don't even tell them. So here from line 2 to 7, I would just say that before the constructor, right? You are just defining the fields, and each field has the word private in front and has the data type before you have the name of the field. But here in the constructor is where you actually assign the values. So I would actually do something like this. So I would then ask, what happens when I click the run button when there is when I've created a Fox class? Shouldn't we already see a Fox in the world? I mean, the answer is of course no. And the reason why it's no is because we actually never created the object and never put it into the world. So, and then I might ask the students, well, how do we do it? And then I would give them a hint, take a look at the game class, and they would look at the game class and say, oh, wait a minute, this is where I actually have to create the ball. So maybe by extension, maybe this will work. And lo and behold, this will actually work, and the fox is right there. So it kind of illustrates also the fact that all the concepts that we talked about, all these concepts gets to be illustrated. Yeah, I won't, at this particular point, I actually won't talk about decorating a room because there's actually documentation that we're putting together that you get to see, so I don't want to spend too much time on it. But that's basically how I would run my first lesson, if you will. So I could, from here onwards, you know, there are many different routes that we can go. If I want to look at my second lesson, for example, I would start asking them, I would start talking about, you know, animation, because that always gets people excited. And I would introduce, and animation is good to introduce the fact that there are things that we could repeat when it comes to computer programming. So I would introduce something, what we call the loop method. So here, let's take a look at this this world that I've prepared, share.c3d.io/f, and take a look at some basic /f, and it will bring me back to here, where now, in addition to having the ball, the boring ball, the balls actually appear to be spinning. And I would start explaining. I mean, sometimes in class, I would actually go over this with them in a lot of detail. Here, I introduce an additional field called rotate Y. So once again, in java.c3d.io, when you create a class, there are about 9 special fields. Right? You've already seen X, Y, Z. And you have seen a model, and you have seen the texture field. There's also rotate X, rotate Y, rotate Z, along with another field called scale. So here I'll show you how scale looks, how scale works. So by default, scale is 1. It means that it is size of unit 1. But if I increase this, then the size will be much bigger. So in this case, scale is actually, imagine if this is a ball, scale would be the radius of the sphere, so to speak. So you can change the size of your objects that way. So there's a total of 9 fields, I believe. X, Y, Z, rotate X, rotate Y, rotate Z, texture, model, and scale. But the magic here that I want to look at for students is that I've created another method called move. And in move, I am modifying the rotate Y to increase by 1 unit. And this is in degrees. So unlike a lot of programming languages where when you get to the math rotation or just angle description, a lot of the other programming languages, they use radians as a way to express angles, and that's the proper mathematical way. Here in java.c3d.io, we use degrees just because I figure a lot of students are more familiar with degrees than with radians. So this is basically increase the degree by 1. So here I would explain what plus plus means, or if you don't want to explain plus plus, we can actually just write it this way as well. You know, that works just as well. And maybe I'll ask them, hey, you know, how do you make it spin faster? How do you make it spin slower? So I mean, the answer is that you do this, right? You know, you can change this to spin. But here's the mystery though, like why does it move? Just because I have a move method, why would the ball start spinning? Well, the key is actually the mystery is actually in the game class, and there's a lot to explain in the game class to make sure that they to explain some of the concepts, right? So here there's a new method that I've created in the game class called loop. So here I would tell them that, you know, loop is kind of a magical method in game. So there's a couple of magical methods in the game class. When you create, game class is what we call the entry point of the computer program. So in any computer program, inside java.c3d.io, there's actually 2 classes, like what we've seen in the last lesson. For these 2 classes, they interact with each other. Game is what we call the entry point. So we don't need to create a new game object because it is the entry point. So the operating system, if you will create it for us. We'll create a game object, and there's only one game object in the computer program, because the operating system is responsible for creating the game for us. But within the game here, you can see that I have a ball object expressed as a field. So bringing all the concepts that they learned from last lesson into this particular lesson. And in the game constructor, I would create what we call the env object, which controls the 3D environment, and I create a ball object here. So you notice that I'm creating these new objects inside the constructor. The start method is another magic method within game, and the start method basically is called when I start my computer program. And as you can see, that there are methods that I can call into the env object to control how the environment looks. For example, in this first line 17, I am controlling the camera and the camera location, but I'm also adding the ball object into the environment. So if I comment this out, for example, the ball will no longer be there because I haven't added it into the environment. And the last line is that I actually have to start the environment. Otherwise, things won't render properly. By starting the environment, one of the things that the operating system would do is to call loop 30 times per second. So I would explain that loop is actually a method that is called continuously by the operating system 30 times a second. So here, when I call ball with inside the loop, ball.move, this method will be called 30 times a second, which will cause this method to be called, and which will cause the ball to rotate. So there's a lot of back and forth in between how these objects are communicating. And this is where we get to go over a lot of the concepts and reinforce a lot of the concepts. So this would be, and the end result, the students can actually see some visual payoff, if you will. So here I can add a couple of these. You can see what I am interested in doing. No, here, let's change it into a tux, for example. And you know, when I do this, then I now have a cute little penguin that's been spinning, and so on and so forth. So I can actually once again, here I would stop. I mean, there's a lot of concepts already. But then I find that if I give them the basic template, I can have them start animating things back and forth. One of the interesting things that you could also do is, let's say if you switch this back to a ball, we can ask students, hey, can you make the ball actually move and roll in a realistic way? Let's just say that the ball starts, because X starts here. So the ball starts here. Can we animate it so that the ball would roll properly? And what they would do is that they could try a bunch of stuff, right? Like this, rotate Z, I think. Let's see what rotate Z would do. Rotate Z would look like this. Oh yeah, so you see here, rotate Z looks like that. So they will have to say, oh, maybe I can do a minus, then you spin that way. But then the ball is just spinning, it's not really rolling. So they would have to do something like this as well. So they would have to manipulate the X location, X plus, let's say, 0.01, because it's a 10 unit. And so if I click on run, then it starts looking a lot more realistic. It looked like the ball is actually rolling. On the other hand, though, I mean, it's not exactly rolling in the right way. So there seems to be a relationship. This is really something that I love to talk about, right? Let's say if I make the ball roll faster, then of course it doesn't look realistic anymore, right? When I increase the speed of of how fast it spins, I also have to somehow increase the speed of the ball. But what is the relationship between this number, the degree, and this number, which is the how far do we go, how far do we move in the x-axis? And that actually is the relationship between the circumference, and it is a radian calculation. So I love to, when to my undergraduate students, and I think that, for more advanced students, for more advanced high school students, that they would appreciate the tie-in between kind of 3D geometry into the actual theory of geometry, because basically that is the relationship, and that's where radians come from, is the circumference of a circle as angle calculation. Anyway, that's just something fun that I like to bring in to my class, but they don't really need that if they want just some fun little visual animation that they can create. And then from then on, I mean, the sky is the limit. So here, that's just some of the follow-up questions. And of course, you can throw in multiple balls in there. I could explain things like, how do I create multiple objects that don't land in the same location, for example? So this is another nice little exercise. Actually, I'm going to put back in the X just for fun here. So let's just say that this looks somewhat realistic. The problem, of course, is that if I want multiple balls, I mean, how do I do this, right? Here. Let's say I create ball 2. Ball 2 equals another ball, and then I add ball 2. You will notice, I mean, and then I can move ball 2 as well, right here. So you'll notice that it doesn't look like we have 2 balls, even if I created 2 balls here, right? If I don't move ball 2, then you'll see that we do indeed have 2 balls, but they are superimposed on each other, and that's why we don't get to see it. So how do I create a ball that lands on a different location? Well, we could create a whole new different class with a different constructor. Basically, we can copy and paste this code, and that's what I would do with the students, and have them try to figure out. And then I want them to ask me, well, then what do we want? Like 100 balls? Do we need to create 100 classes? So this is where I would explain that, you know what, that's actually when we create the ball, we could actually provide it with additional information to control where the ball is located. So we could here just what we call a parameterized constructor. So this is how I would explain the concept. So that's it. That's how we can reuse this ball class, but create the flexibility of having the object being provided by game. Game can now control where the object goes, right? When we create a ball class, you see in this previous version, when I create a ball, I will have I'm just calling the constructor, but I don't give it the information. That constructor no longer exists. The new constructor actually expects the game class to provide the X, Y, and Z location. So here, if I run this, this actually won't run because it says here in line 10 of the ball class that it requires, or actually no, line 10 of the game class. It says that it requires 3 doubles. So that's your basic Java error messages here. So what I would actually do is put something like this: x is 1, y is 1, z is 1 here, and I can have another ball that x is 3, y is 1, and z is 5, or something like that. And so with this, I can now land 2 balls. As you can see, the 2 balls are right there. I can control, when I create them in the game class, I can control where they go. I'll put the ball much further out, the second ball, so you can see that, you know, it looks like the 2 balls, and then they can move independently, and so on and so forth. So this is where I would also I can potentially introduce the idea of a parameterized constructor, which further reinforce the concept of object-oriented programming, where we are indeed creating the same ball, but with different kind of initial parameters, initial conditions. And we don't have to keep writing new classes over and over and over again. So that's another concept that I would explain to my students using these few lines of code. And of course, then they can start being creative again. There are also a lot of facilities in terms of things like how to take user inputs, how to create and eventually I would explain things like arrays, taking user inputs and then have them complete a project, you know, and that would end the term, because that's actually a lot of concepts already. And when we talk about arrays, of course, we would have things, interesting concepts like how do we loop over an array, and I can explain repetition, and then we can explain conditionals as well when we take user inputs and so on. So that's just a lot of concepts that we could use this tool for, to explain all the major computer science ideas to students. So here's a fun example with arrays that I like to show everyone. I think it's called /G. So let's say share /G. Here in this example, you can see that I have a monster looking thing that's actually being animated. So if you look at the monster class, it looks very similar, but I'm now using what we call an array list. And I add all the different OBJ files, and each OBJ file has a different geometry, but they are essentially frames of an animation. And so if you look at the move, the move method essentially just replace the model with the next model in the sequence, and it creates a cute little animation. So that's something else that we could show students. And I have a lot of these predetermined models. Let's say the boss character is the monster that you've seen, and you can see that in the idle, this is where all the OBJ files are. So I would continue to explain how to use array lists using this particular approach, and have them explore some of these different models. And students generally really enjoy that. So finally, I have some fun little things. So if you go to this share/1, this is a really advanced project or advanced example, but using all the similar concepts. And here in this particular example, I'm also using concepts like inheritance and so on to create this particular simulation. As you can see this in this simulation, right? I have a lot of foxes, and let's run it again. And all these foxes are randomly moving around, try to infect, so to speak, the tuxes. So when a fox touches a tux, the tux actually becomes a fox. So this is a cute little animation or a little simulation that I can that I put together using a lot of the concepts that we have talked about today. But I figured that since we are all talking about COVID-19, so I created this particular example and in the game class, there's a couple of parameters that we could adjust. For example, how fast these creatures moves and how long the foxes actually live. As you can see, the foxes don't always infect all the tuxes. Foxes will die after 300 turns or 300 loops, if you will. So you feel free to look at the code, but I just want to concentrate on these two parameters, kind of for fun here. So as you can see, the foxes don't always completely annihilate the entire population. It could be a couple left. But if the creature's speed is increased, for example, then the chance of foxes completely annihilating the tux population is pretty high. So imagine foxes are the infected. And the infected will eventually die. And before the infected dies, if it touches an uninfected person or uninfected creature, the uninfected creature would become infected themselves, and then they would eventually die as well. So if the faster the creature go, the more likely the population would be annihilated. But if the creature moves, all the creatures move slow, simulating the effect that we have some kind of a social distancing policy, if you will, where we don't move as far or as fast, then it is much more likely that we will have a population that's remaining, that infection rate would be slow. As you can see, by changing the creature's speed to a lower speed, we are more likely to have more tuxes left over. And if we make this even slower, you can see that they hardly move. Then, of course, even when they do infect, because they hardly move, the chances of the foxes dying out before they get to infect someone is much higher, meaning that we eventually will have a population. You see here, we still have some level of infection here, but eventually this will die out. Hopefully, this fox would die. Oh, yeah, you see, before it dies, it managed to infect people, but the infection is just localized right around here. And as you can see right now, that because they move so slow, most of our population is nice and healthy. So using all the concepts that we talked about, eventually I hope that you can see that eventually you could keep explaining all the concepts and keep showing them interesting examples that we will be able to cover all the major concepts of the first year computer science curriculum, which also happens to be the first year AP computer science curriculum as well, and provide them with a lot of interesting examples and a treasure trove, if you will, of new ideas, and allow them to be creative and enjoy the process at the same time. And if they actually click on this button, they can share their code with other people as well. And just like if we click on this button, for example, it will actually generate a URL, a share URL that they can now copy to and allow and pass to others. So it's easy to share their creation with others as well. So at this point, I open open up open up the floor to questions and discussions.
This is Arsh. Great presentation, by the way. So I was wondering if we can have something called threads or synchronization on this platform.
Uh, in uh, in the in the original Java version, yes, I mean, because it's based on real Java.
Uh-huh.
So yeah, I do talk about threads and things like that. I think that for the web version, I haven't explored it. I don't think it's possible just because it gets transpiled to Java. Basically, the reason why the code runs so well is because it gets translated into JavaScript, and technically, that is JavaScript doesn't have the same idea of threads. Although we could explore workers, which I haven't done yet, so I couldn't tell you. I can tell you that in the actual Java version, though, I did have a bunch of exercises on threads, but not I haven't explored here yet. So unfortunately, don't have an answer for you at this particular point.
Yeah, that's okay. Anyways, that's a very advanced concept, right, for the first year students?
Yes.
Yes.
And so I wouldn't usually the threading concepts I would incorporate as a much more advanced concept that I explain in a second computer science class.
Mm-hmm.
Yeah.
Jason, could you talk a little about how is this thing being put together? What is happening actually in the back end?
You okay, yes. You know, what's actually happening in the back end.
Uh-huh.
Yeah, so let me maybe share the screen a little bit. Yeah. So on the left hand side, this is a Java code, right? But on the right hand side is a window that is really running JavaScript code. So on what happened is when you click the run button, the Java code is sent to a backend server, to actually a backend pool of servers. And what happened is that backend pool of server runs what they call a transpiler. And the transpiler converts the JavaScript into what they call TypeScript. And I found a transpiler called jsuite.org. If you visit jsuite.org, you will be able to find that particular product. And it basically converts your Java code into TypeScript code. The TypeScript code then gets sent back to the browser here. And the browser would convert the TypeScript code into JavaScript code to run. So that's actually quite a few technologies at play in order for this to work properly. And the reason why it can be done so quickly is because at each point in time, well, first of all, these programs aren't huge, but each translation is actually fairly straightforward for the particular system. To convert Java to TypeScript, because TypeScript is a programming language that is very similar to Java. It is actually a cross between JavaScript and Java, right? TypeScript is right in the middle. So that translation, although it has to be done on the server, it can be done fairly quickly. From TypeScript, when the TypeScript gets sent back to the browser, the conversion from TypeScript to JavaScript actually takes a little longer. That's why I'm not doing it on the server, because then if everyone's doing it, then you'll load down the server. So I make sure I send the TypeScript back to the browser and have the individual machine, individual browser converts TypeScript into JavaScript. So that the heavy duty conversion of TypeScript to JavaScript is done on the browser. And because there's actually not a lot of code, that runs pretty fast as well, because we are now distributing the load to each individual device. So it's kind of taking advantage of the distributed version or distributed nature of running things on the client. And it was through a lot of experiments that that we get to balance all of those systems components to make sure that things runs at a decent pace.
That's very interesting. One question, but why did you choose Java and not any other programming language?
Oh, it's because back in 2007, everybody, or 2006, everybody was doing Java as their first year programming language. I was assigned to teach a Java class, and I find the textbook extremely boring. So I started building this thing off of the Java platform, you know. But the concepts, on the other hand, can be changed, right, to accommodate other programming languages as well. I think that the bigger vision is that we will have different versions of the programming languages. Like Java is just one of them, but we could have Python. We've got a Python version. We already have a Blockly version that we're pushing. It's actually the main product of Codica called, just if you go to C3D.io, you can see the Blockly version. So I think that's the bigger vision, is to start launching multiple languages onto this common platform, because this platform of 3D visualization and VR visualization, we find that there's a lot of value in students having access to this particular platform. So yeah, I think a much bigger vision is to have lots of different languages.